All right, let's go ahead and get started. First of all, thank you for joining me. My name is Michael Ann Lane, and I'm the Global Education Manager for Hexagon Geospatial. I would also like to acknowledge the National Council of Geographic Education, the NCGE, for their assistance in marketing and helping us to get the word out about this webinar. Today I'm going to talk to you about how technology is revolutionizing the way we study geography and use location-based information. Personally, when I declared I was going to major in geography almost 20 years ago, a lot of people were quite skeptical. They asked me what type of career I was going to take besides teaching that I could have. Aren't you limiting yourself? Won't it be hard to find a job? But little did they know we were about to embark on a new age of geospatial science. Back then, when you thought of geography, you thought of memorizing states and their capitals, which rivers flowed through which continents, where volcanoes and glaciers were active or dormant, and of course, how to read a paper map. And although these are still definitely important, I think we can all agree that a lot has changed in the past few decades. It's very hard to remember a time when we couldn't type in an address in our phones, and it would give us the best possible route to the destination, even avoiding traffic. This new technology and some of our modern-day conveniences, it's because of this new location-based information. Geographic data that is collected, and we are solving problems with it. So how do we use this technology revolution to prepare our kids for the new age of the study of geography today and what is coming in the future? Without geography, you are nowhere. And this is very true. If you think about it, every single thing we know has a specific location on the Earth's surface in our three-dimensional world. So how can we harness that information to help us make important decisions? In today's webinar, we're going to go over several things. First of all, a little bit of history, where we've come from, and where we are in the present. But then we're going to talk about what we think is the map of the future. So the map of the future needs to be smart, and we're going to talk about smart maps and essentially what you need to have in order to create a smart map. Stay tuned because I'm going to do an actual live demo, and you're going to watch me create an interactive experience with an app displaying something fun that kids all know and love, and that's amusement parks. Then we're going to take a look and think outside the box, and I'm going to show you some other examples and ideas that I hope will get you brainstorming on projects that you could potentially do with this platform. Then we're going to ask some important questions. How can I use smart maps in education, and specifically in geographic and geography education? Next, we'll look at the benefits of using a platform like this one in your courses. Then we'll talk about how you can join the Hexagon Geospatial U community with like-minded individuals to share ideas, courses, and so on. In conclusion, we're going to take a step back and look at our common goals and objectives, and finally we'll have some questions and answers at the end. Feel free to type your questions into the chat box, into the WebEx. I'll do my best to get to as many as possible at the end, but if you do type a question and you don't hear the answer during the WebEx, I will definitely follow up with you after the WebEx personally. So go ahead and type those questions in. You're all on mute now, so use your question box if you have any along the way. To know where you're going, it's always good to know where you've come from. We've all used paper maps. Does anyone still use them out there? Do you teach them? Maybe you have one in your car in the glove box as a backup, just in case. Paper maps were important as we mapped new worlds. They were important in getting from point A to point B and place to place. They were important in learning about our world, places we've been, and maybe places that we haven't visited just yet. Then came along computers and the digital technology revolution, and we arrived at this digital mapping generation. Paper maps were digitized and turned into information stored on computers and displayed as images. New sciences were created, one of the most common being Geographic Information Systems, or GIS. And if you aren't familiar with GIS, it's the science of stacking several types of maps or layers on top of one another to get answers. Remote sensing and photogrammetry were also created. And if you aren't familiar with those terms either, have you ever taken a look at an image from space? Have you ever seen your house on Google Earth? Well, if you have, you're practicing a very simple form of remote sensing. There was a new entire world of collecting new data digitally, capturing pictures of the Earth, first from cameras on pigeons, then on airplanes, then satellites, and now we're even moving to drones. We are in an age of collecting vast amounts of digital data. So much digital data on a daily basis, it's very hard for us to even comprehend. So what do we do with all of it? Geospatial professionals take this data and turn it into valuable information, creating complex solutions and solving real-world problems. They deliver mapping information online quickly, efficiently, seamlessly, and effortlessly. And we as consumers then use that data that has been transformed in our everyday lives. A Greek philosopher once said, "Change is the only constant in life." And with that change comes physical change in our environment, building new building developments, or maybe natural disasters that cause our landscape to change, and then we need to map them again. So whether it's the paper or digital mapping generation, the maps of today remain static. They're not alive. They provide us only a look of the past. Have you ever looked on Google Earth and seen your neighborhood, but from 2 years ago? Digital maps that we have so much information embedded in them, but when we really look at it, does it give us intuitive information and actual answers? Maps cater to a stale and flat experience, an experience void of real communication. They're only providing a form limited to the 4 edges of your map, your screen, or display. So why shouldn't technology help us to actually represent what we see and how we experience our lives in our 3-dimensional world in real time? So let's start to look at the future and the map of the future. What are some of the characteristics that we need for this map? Well, it must be fresh. It needs to be updated and new data. It needs to provide me with exact answers, the ones that I'm looking for. I want to be able to use it on my desktop here in Colorado. I want to be able to use it on my tablet out in the field collecting data, or even on my mobile phone. And it needs to make sense to anyone looking at it, whether you're 5 or you're 95. What good and why are we collecting quintillions of bytes of data if only a handful of rocket scientists can really understand it? So the map of the future is not really a map at all. It's an app. It's an interactive and dynamic application that not only tells us what was, but can also tell us information about what is, insight into what can be, and trust and confidence in what will be. The app that I want to focus on today is called Feature Analyzer. And when I think of Feature Analyzer in education, the potentials and the possibilities are endless. Feature Analyzer is all about taking data and displaying it in a meaningful way to understand it, study it, draw conclusions, and provide answers. Now let's break this down. Let's think of the word app. Think of all the different apps that you have on your phone right now. Maybe you have an exercise app that's attached to your watch and it tracks your progress on a daily basis, your sleep, and so on. Maybe you have a social media app on your device to connect you with others, with their photos, their ideas. We all probably have some games on our devices as well, some entertainment, and to have some fun. You also may have some location-based apps that you may not even realize are location-based. So if you use biking or hiking trails, like I use in Colorado here, or maybe you go to a new place and you want to find the best reviewed restaurants in the area. These are all apps that use location-based information, your proximity and your location, to help you to understand your world. So what do all these apps have in common? Well, apps are specific. They have a specific purpose. They're targeted. Hopefully, if they're done well, they're easy to use and easy to understand. If they're difficult and not user-friendly, not that many people are going to use them. And they're regularly updated. They all have regular updates to keep them fresh. So the creator of the app can fix any issues, make improvements from suggestions from their users, change the interface or icons, but they're updated regularly and they're kept very current. So how are the apps different? Well, apps use different input data. Obviously, if you're using a specific app for exercise, the data that's coming in is your own data and tracked. If you're using data for a restaurant, that's coming from a different place. They also provide you a different user experience. When you open the app, they have different interfaces, and you interact with that data differently. So let's take a look at that different types of input data. When you're talking about Feature Analyzer and the data that you need to put into the app, there are 4 different types that I'm going to explain to you. And this is important because during the live demo that I'm going to demonstrate, we're going to have a feel for these different types of data sets. So data can be points. And when you think of points, these are X and Y, or latitude and longitude, like every place on the Earth's surface. The format that we need isn't just a simple Excel spreadsheet. So let's think of what some points could represent. Your school, for example, has an X and a Y coordinate. It has a latitude and longitude. What about the trees on your campus? Each one of those also has a specific location if you wanted to map your trees. Bus stops, where your kids get on and off the bus, are also points. If you're looking at sustainability, trash, compost, recycle bins, all these receptacles also can be mapped with points. If you're looking more on a broad scale, you can look at cities in your state, maybe capital cities in the United States. If you're playing a game, it could be cities that you visited or that you would like to visit one day. The next type of input data that we can use in the Feature Analyzer app are lines. And lines are simply connecting the points. The fancy way of how we say this in geospatial world is polyline. So what are some examples of lines? These could be streets or sidewalks in your neighborhood, maybe your school bus routes, public transportation lines, maybe even rivers. Maybe you can think of some other examples. Next are areas, and our fancy way of saying areas are polygons, and they are enclosed spaces, parcels, for example. What about school districts or zoning districts? Also examples of areas or polygons. Voting districts, counties, states, countries, all of which represent areas. The last one here is a web service or RSS feed, and this is typically a service of constantly updating data. If you've ever watched the weather and you see the weatherman talking about weather moving through and you see the active radar and the weather on the map, this is an example of a continuous web service or data that's being updated constantly. Another example are wildfires. You could have reports of wildfires coming in constantly and therefore the data online being updated. You can use this type of data in Feature Analyzer so that your map and your app are truly dynamic in nature, meaning every time you log into the app and you experience something new, something changing, something in real time. So these are all the different types of inputs that we can use with Feature Analyzer. Next, we need to talk about attributes. This is a fancy way of saying geospatial metadata. Metadata may also be a fancy word for saying information, descriptions, or specific characteristics about a point, line, or area of interest. So certain things may have an attribute like a name. Your street has a name. Certain things may have a location, X and Y. They have a description. They might have a class or category, a price, cost, or value, and they may have an owner. These are all just examples of what attributes could be. Now, the example that I'm going to go through in this amusement park here, this is the exact data that I'm going to show you and use. You can see here the name of the amusement park, the attractions that are at that amusement park in Florida. These are all in Florida. The classification, notice here there are 4 different types of classifications: amusement park, water park, visitor center, and theme park. The admission, or the price that it costs to get in. A latitude and a longitude, and you can have as many attributes as you like. So you could also have a web address, a website, anything else that describes each one of these different amusement parks. So where can I get this data that I need to put into Feature Analyzer? Well, you can use your favorite search engine and search. There's all kinds of free downloadable data out there, some that's pretty much ready to go to simply drag and drop into the app. There may be a little data preparation, but there's some quick and easy tips and tricks and instructions on how to do that. You can search and find free downloadable documents. You can create your own spreadsheet manually. And that's exactly how I did the one that we're going to use in the example. I searched my favorite search engine. I found a list of all of the amusement parks in Florida. I went to each of their websites, and each of their websites on Wikipedia gave me an X and Y location. It gave me what attractions. It gave me a price of what to get in, how to get in, or how much to get in. And I simply copied and pasted those and put those into a spreadsheet. And I'm going to show you how I use that. You can make up your own data to teach a concept or to play a game. It doesn't have to be real-world data. Sometimes it's easier to search and find some and download it, but you can definitely make up your own. And I'm going to show you a couple examples of this. We also have tutorials available and existing example data sets available in those tutorials as well. All right, let's move into the example now, the exciting fun part. So what I want to show you is Feature Analyzer. This is the app. I have logged into the app from our website, and I'm going to show you our website at the end, so stay tuned. But I logged into the website and selected the app I want to use, which is Feature Analyzer. And this is what I see. It's a blank slate. I can collapse the tools or expand them, and you're going to see in the background here in just a minute that it is a background map. It's a free background map that we display. This app here is through a browser. My browser of choice is Chrome, but if you use Internet Explorer, you can use that one. Any browser here of choice, it's simply a URL that you are getting to access this app. Okay, so how do I begin using this in just a few simple clicks? Well, remember I said we had this amusement park file that I created manually, looking at Wikipedia and doing some copy and pasting. Okay, here we have the state of Florida, that's an attribute. The name of the amusement park, which is also an attribute. The attractions, the classifications, the admission, latitude and longitude. Please notice this, lat and long, that I've labeled the attributes. And then a couple others, videos from YouTube of the amusement park, a web URL, maybe an image. As I said, you can have as many of these as you would like. So I save this as an Excel spreadsheet. That's it. Easy, simple. So I'm going to take that Excel spreadsheet in my tools, and under my feature data here, I'm just going to simply drag and drop, and there I see amusement parks. Okay, so a simple drag and drop of my data and click Apply. And what's going to happen here is I'm going to collapse the tool so you can see It's now mapped the amusement parks in my Excel spreadsheet using the latitude and longitude coordinates. Okay. The single ones here are amusement parks, and then you also see a cluster right around, imagine that, Orlando, where Disney is, and we see a cluster of 9 of them. If I zoom in a little bit closer, depending upon the scale, you're going to see this burst, and you'll see the different amusement parks then here. So I can zoom in and zoom out of my map. So in 3 short clicks, I've mapped something already within this app. Now we want to get a little bit more fancy. So let's come to the tools. And the way that we work is from left to right. So we've already put in an Excel spreadsheet with the points. If you've got any boundary data, this could be state boundaries, areas, you can put that in here. And then you can also collect and view templates. And templates are things that you can save and apply to other smart maps. They are really all about how the template and how the map is saved and viewed. And I'm going to talk about one of these in the examples in just a little bit. Okay, so the next thing we do is move to the next tab. This should look familiar by now. This is the attributes that have been copied over into the app itself. And I can see here under the Geometry Field tab that the app is smart enough to understand that latitude is latitude and longitude is longitude. So it recognized these from the columns, and it went ahead and placed them there, and that's why we get our points on the map. Next, we're going to look at a theme. And the theme here is one of the things that the attributes we want to display as a pie chart. So the one that I really want to look at as a pie chart is this one here, this classification, the one that has 4 different classes. So I'm going to choose the field name here, classification. It's going to expand a bit, and I want every one of the pieces of pie in my pie chart to be a unique category of each of the 4 classifications. So I'm going to click apply, and there we have, in an instant, a pie chart that represents each of the different classifications. I can give this a name if I would like. I can type this one as type of part and apply that. Notice here, every time I apply, the changes are made on screen and I can immediately begin using them. So let's collapse this and look at them now. The points are all corresponding to the different colors here that I have on my pie chart. If I'm only interested in amusement parks, I can select amusement parks and filter my map so that everything else is hidden. The 3 other types are hidden, and I'm only seeing amusement parks. If I want to see the full view again, I can hit reset. All right, great. So we've started already with a pie chart. Let's continue. The next one is functional attributes. Functional attributes are a bit more complex. I'm not going to show them in this demo. This demo I'm going to keep very, very simple. But you can learn all about this in some of the tutorials that we have and use this, which are a very powerful feature. Next are our colors. You'll notice here that I have some different clusters of colors. You can change any color that you want, any of the different colors of the rainbow you can use. You can use different sizes of cluster markers depending upon how much data that you have and the size and the shape that you want those clusters to be in. The next thing we look at is chart configuration. And in a couple of the other examples I'm going to show you, you're going to see a drop-down list. You can have more than one theme. So you can choose to display the data in a variety of different ways here under the chart configuration tab. Next, we're going to add a few more charts and graphs. So we already have the first one here, which is classification. I'm going to add another chart. And the chart that I want to add is the price or the admission of my amusement park. I'm going to call it admission. And if I look here in the type of chart or widget or graph, please see here how many different types of widgets and graphs that we can actually display in this app. You as the author of the app get to choose which makes sense for the appropriate attribute. So for admission, I'm going to use a drop-down list. I'm going to try that one. If you don't like it, you can always go back and change it, click apply, and reset. So I'm going to choose drop-down list for admission. Move this, and now I can see each of the different prices here for the different amusement parks. This is expensive. It's $104 to get in. Let's view and find out which ones are those. Oh, imagine that. They are Disney, and there's 4 of them here right near Orlando. So I can reset that and go back to admission to show all of them. I'm going to add one more chart here, and that is the attractions. What is actually at these parks so that I can pick my favorite park that I want to go to. So instead of admission, I'm going to choose the attractions. We'll call this attractions. And the type of chart that I want to display here is a text search. I want to know which ones have roller coasters, which ones have water slides, and so forth. So I'm going to choose a text search, click apply, and there I see my attractions. If I collapse this, I can then say, all right, which ones have roller coasters, Ferris wheels, go-karts? And I can see that one has all 3 of those things. Okay, which other types of attractions might we want to see? Something with a water park, water rides, water slide. There we go, and we can apply that, our water park. Okay, so that's great, what we've done so far, but I want to know the name of this park. What is this, actually? I want to display some of the attributes on the screen. So let me reset this and go back to the tools. We're going to come back to this one in just a second, but first of all, we're going to do the tooltips. And tooltips are going to give me the ability to place attributes when I click on the screen and show me the different attributes there. I'm going to add 3. And the first one that I want to use is the name of the actual amusement park. The label is going to be name. Next, I will choose the amount to get in. And then finally, I will choose the attractions. And you can change the name and label of these all you would like. So I'm going to click apply. And then I'm going to collapse. Now, in order to turn the tooltips on, I have to do one more tiny step, and that is just to show the tooltips. So I'm going to apply that. And then finally, if I come over to one of these, I can see those 3 attributes that I just specified. The name of the amusement park, how much it costs to get in, $0, great. And then the attractions and what it has in it. Now, here's where we can start to ask children a lot of different questions, right? We can ask them, if you have $30 exactly and wanted to spend $30, which parks could you go to? So they can start filtering on $30 and find that they're 2 different parks. What if we only wanted to go to a theme park? We select theme park. What park is that closest to? What city? What ocean is that park the closest to? What's the name of the park? What are the attractions that are at that park? All different types of questions that we can ask students doing critical thinking after they build something like this and have a good time building it. So lots of cool things we can do. We can take a look at the background map. So as you see here, we've got just a nice base map, but we could do fun things like aerial imagery and look at satellite images underneath. We can look at a hybrid or look at traffic. We can change different schemas, whether we want to look at it from the nighttime or the daytime, all different types of fun things that we can do with the background as well. Next, what we have are the ability to place logos. If I wanted to place my school's logo in here, I just simply need a URL and it will display, and I can change labels and customize it to my very own. And then I can also change look and feel of the app. I can change this to green, and I can change this to another font, maybe Comic Sans, and click apply and change the look and the feel of the app as well. So all different types of things that you can do in a very easy way in a graphical user interface using drop-down lists. If you're more advanced and you want to try something like functional attributes, if you're a developer and you want to use JavaScript, you can also implement that. So this is a completely versatile app that can be started with, I use this with middle schoolers and 8th graders. They built this app in less than an hour. You can show kindergartners and demonstrate for very young children as well. And then in high school and maybe even into college, they're collecting their own data, downloading their own data, and really understanding and drilling into the data to make sense and make more sense of the data that they have. So very, very quick and simple example that I did that is fun, creating the data myself manually from the internet. Let's look now at a couple other examples. These are going to be a little bit more complex, but I'm hoping these will get you brainstorming on different things that you can potentially do. This one here is displaying at the top. You can see it's again through a browser, a URL. It's displaying 4,889 citizen-reported reports or problems in San Francisco. So San Francisco has citizen-reported problems in which their constituents can report things that are happening in their city, and they can log those into a database to hopefully get them fixed. That's the goal. You're seeing a lot of different clusters here, and you're also seeing some hotspots, a layer of hotspots. The most incidents here that you're seeing, 605, is red. And then as we go gradually out and decrease in number, the colors change in the clusters from yellow out to green. And you see that with the layer here. This is a layer that you can turn on and off if you don't like it. So now let's drill into some of this data. If I zoom in, of course, the clusters will burst open and I can start moving into the data and seeing things more specifically. Well, what are the attributes of these citizen-reported problems? What's the category that we're looking at here? These can be anything from damaged property to graffiti, anywhere that litter receptacles may be broken or overflowing. There may be a sign that needs to be repaired. So we can filter on any of these categories. And I want to take a look at graffiti on public property and click Apply. Notice the map then adjusts and changes and updates interactively. So now we're only looking at 294 of the incidents. And I have several, just one incident here or there. I can click on a cluster of 2. And what I see here then, if I move over, are the attributes. And the author of this specific view or app wanted to display these particular attributes to the user: the address, the case ID, the category, the latitude and longitude, and I'm going to show you another example that even has photos. So let's click on one of these things, and we can open up one of the single attributes to see all of the same things: the address, the case ID. If people are taking photos, we can embed the photos in there as well, even movies. So we can embed movies into these things to give us a better picture of what things look like. So think of anything else that you could do on your campus with points to interactively interact with them and show spatial patterns. Maybe there is some graffiti that's happening and you can see it on a timeline. Maybe we're looking at July and June, and you can see it gradually moving across San Francisco. So how might you go about and send law enforcement to perhaps find the people that are making and doing that graffiti and destroying the property? So another great example here for San Francisco and citizen-reported problems using crowdsourced data. All right, the next one that I want to show you is also points, but is a bit more about demographics and schools. So the Ministry of Education in Kenya has collected data for a number of students enrolled in the primary school, so class 1 through class 8, including the number of boys and the number of girls with both private school and public school for each of their 47 counties in Kenya. So how can we determine, and just a few short clicks, understand this data graphically and to give us some real answers? So we see here that this is displayed, our theme is by class. So first grade through to 8th grade. Now, this also has another theme where I can display by county. So my first problem, or my first question, is that I want to see how many boys are enrolled in public school in Baringo County. So the first one here is Baringo County. I'm able to either click on the pie chart, the label on the legend, or if I know which one is Baringo County in my map, I can also click that one as well. So I can click on Baringo County, and there I see the number of the total enrollment of students, boys and girls, both public and private schools. My question is, how many boys are enrolled in public school? So let's click on boys, and let's click on public school, and we can see the answer right here. The total enrollment on this gauge is 67,489. What about girls? Okay, slightly less. So a great way to see things with a spatial reference, as well as some different demographics and statistics about our schools. Now I'm going to reset all of these, and we're going to answer one more question with this one. I want to see how many boys are enrolled in the first grade in both public and private schools for all of Kenya. So in the top chart, I'm going to change it to class because I really want to look at first grade. So I'm going to select first grade, select the pie chart, and I'm going to see the total number of students that are enrolled in the first grade. Now I want to know the total number of boys. So I'll select boys, and I'll see 712,131. Select girls, and I see slightly less. This enrollment chart is interesting. So the enrollment bar chart indicates the number of students in the entire county for a particular class size range. So the x-axis is the number of instances, and the y-axis, or rows, is where the class size range falls within that value, such as 2,500 to 5,000. So think of all the things that you could use with your school district using something like this. The demographics of your students, test scores. Could you present something like this to stakeholders to ask for funding, proving a point, by really drilling into the data and understanding it more and showing it in a reasonable way that makes sense for people to gather? It's so much more effective than showing spreadsheets. A picture's worth 1,000 words, so these are really, really great ways to communicate information to people that it just makes sense. The next one that I want to show you is working with areas. And this is our student contest winner from last year. So it's important to note that this one is feature data that is simulated. This is just simply proving a concept, so it's not real data. She made it up just to simply look at the data and to understand a prototype. So this is all about the moving parts of a refugee camp and how we can see different things happening: the spread of people, the spread of disease, the spread of where medicine may need to go, where food, where supplies may need to go. So a really interesting concept about layering data and understanding where things are moving around. So this was part of her project, and I just wanted to share this view with her. So this one's looking specifically at disease and a couple different types, diphtheria and measles. So I want to look at specifically this one, measles and rubella. So when I select that one, I'm going to see it narrows down the number of cases of illness. Now, I may only be interested in the females in the refugee camps that are aged 13 to 46 and that may be pregnant. So yes, so it's going to be very important to understand where these people are and how we can get medicine to them and vaccines and so forth. So, well, this is great. We know where they are, but where did that start? Where did the disease originate? Let's take a look at the timeline and the date. So I can start looking at these things and moving my date and expanding to see where the first case was. And then as time goes on, where the second, same area, third, fourth, fifth, and how it's spreading throughout this area at the refugee camp. If we continue, we can start to see a pattern. Where is it going to go next? Where do I need to send medicine? Where do I need to send supplies to these women who are pregnant and have some sort of disease? So very interesting concept and great way to layer information and data to look at these things in a real-time scenario and what needs to be done to solve really real-world problems. So great job for Marissa, who did this one. She won a free trip to our global conference in Las Vegas. Last year, she presented her work, and we're having this contest again this year. It is Hexagon Live is in June in Las Vegas. If you're at all interested in joining us, please let us know. It's a fantastic conference, and you're going to see some additional students work there this year. I have one more to show you as an example, and this one is just really for fun. We created this as a mapathon. If you're interested or have seen James Bond or spy movies, this was a mapathon we did at a conference to solve the crime and find out who the spy was. There were a lot of trivia questions that people did every day on James Bond movies and so on. So we called this the global espionage. And if we zoom in, you can see the spies and the hotspots here. This is using one of those templates. So you see the colors in the background and how interesting it looks. You could save these as templates and apply them to new views. So really cool idea to save templates and the color configurations to apply them to other things. So for example, let's say the spy that we're looking for drives a Maserati. We click on Maserati. Now we want to know which one of these spies enjoys skydiving and which one of these spies is from Australia. And the spy that we're looking for is Ilya. So a cool, fun game that we did. And these are types of things that you can do with your students too. Anything of movies, interests that you like, you can create these things and make geography really, really fun. All right, so those are some of the examples that I wanted to show you. So let's move on and let's ask some questions. So are you teaching geography to a group of students? And if the answer is yes, what grades? What specific classes are you teaching? So as I mentioned before, if you're teaching kindergarten or some primary school, you may just be interested in this app to demonstrate concepts and have it for yourself to play games and show them on a screen. I've done this exercise with the amusement parks with middle schoolers. So if you've got middle school students, you can provide them with a login and have them get into the system themselves and drag and drop data. It's only a few clicks and they can add data themselves. In high school, they should be getting their own data and being able to do their own projects. And of course, when they're in university, they can do some amazing things with this platform. If we think outside the box, are you demonstrating statistical information about your school or district to your parents, stakeholders, decision makers, test scores, asking for funding? This is a great tool to be able to look at those things and to prove specific points that you want to make. Now let's look at the benefits. You can log into this app through a browser of your choice. There's no installation or IT. There's no licenses. There's no troubleshooting. There's no, does this run on a Mac or a PC? What are the system specs? How much RAM do I need? None of that. It's all through a browser. All you need is the internet. Okay? If you don't have access to internet or you're on an intranet, we also have an option for building apps within your own organization and not getting onto the public cloud. So that is also an option. It's easy to use. You saw me build an app in 3 clicks. Super, super easy. It's fun. You can create different types of games, and it's so versatile. Kindergartners through to college graduates, masters, PhD, you can make these as easy or as difficult as you like. They scale up and down depending upon your skill level. You can start off very simple, and as you learn more and watch videos and tutorials and play around with the app a little bit more, you're going to learn more as well. So then you can start to do cooler things and add in really, really interesting data. Other benefits are that you can download and use free data. Okay? You don't have to buy data at all. You can collect your own data out in the field, which is an amazing experience for your students to go out, collect data, and then actually plot and map that on an app. What a great exercise they're learning. And then, you can also make up your own data, as we saw in a couple of those examples. So you don't even have to download true and real world data. Join us at the Hexagon Geospatial U community. And in this community, which the geospatial community is open, but the U community is closed to academia. So you can learn how to administer the different users if you want your students to have logins to this application. You can find tutorials here, step by step, on how to do things, even with example data, so that you can learn how to do it. You can view other examples. I've shown you 4 here, but there are literally thousands of them that you can view to get ideas. You can download example data that is ready to go. So not having to do any cleanup, to understand the formats too much, you can just simply download the data and use it as examples when you're teaching. Here you can also find quick links to additional e-training, and our training for this app ranges from a 5-minute quick movie to a 2-hour in-depth demonstration doing functional attributes, JavaScript, etc. So depending upon your range, there's something for you. This is also a forum to connect with other teachers. If you're using this platform, you have done something cool, share it. Then we don't have to reinvent the wheel, and we're collaborating, and we're making this really, really interesting and easy for all of us to share our geographic information. So what is our common goal? We want to make learning and geography fun. Geography isn't just memorizing places and landmarks and features anymore. We have to think outside the box and be creative when it comes to geography and apps and what kids experience in their lives now and in the decades to come. Although some of your students may be far off from graduating and finding a job, a teacher's goal is always to prepare their students for the future. So let's work together and combine forces so that you, as teachers, know what's happening in geography today, what tools and apps you have available, and we, as professionals and industry leaders, will help to provide insightful technology, ideas, tutorials, and games to make your job easier. Choosing to major in geography did not limit my career choice at all. There are hundreds of different career paths because almost every single industry that you can think of have jobs and careers working with geospatial and location-based data. The map of the future is here, and it's helping us to see our dynamically changing world in ways that we didn't even know were possible. So thank you very much for attending today's webinar. Again, my name is Mike Lane. If you have any questions at all and you haven't typed them into the chat yet, please feel free to do so, but also please feel free to email me if you would like. This is also the web address of our store, so where you can find other smart maps in action and look at some different things that we have created for the industry that use this really, really cool technology. You can also just browse the Hexagon Geospatial website to find different links to our education programs, the storefront, and so on. So really good place to find information. And yeah, I hope to continue our conversation with apps. So thanks again for joining us, and I will open the floor up for questions. And I have some people on my team who have been looking at the questions during the webcast, so they are going to read those to me now.
Hey, Mike, great presentation. Okay, so one of your questions that came in was, is there a cost associated with the platform?
Very, very good question, and I'm so glad you asked. So right now, Hexagon Geospatial is conducting an academic contest for this app. It's called Map Madness. It's free to sign up, and you can get access to the platform for free until May 15th of this year, so about a month and a half left. For the contest itself, you can choose any data you like, whatever interests you. We have some that people have done with their favorite concerts and their favorite bands. There's others that have mapped Olympic athletes and where they are from. This month and a half then will also give you time to evaluate the application, to get some practice, get some training, all for free. So if you do finish and submit one of these views with your data of choice, there is a prize. You or one of your students, whoever submits the view, can win a $500 gift card. So not only do you get some training and get to play around with this app, but you could also win $500. So outside of the contest, the app is offered by an annual subscription. So we use Amazon Web Services to host the public app and your data on the cloud. Since space on the cloud isn't really for free, there is a small cost associated with the academic annual subscription. So there's two different pricing. There's commercial pricing and there's academic pricing. So with being part of academia, you get this very, very discounted annual subscription. So really you're essentially paying for the cloud space, which is very cheap, and then the app itself is for free. So you pay a little, but it's for space. I'm really happy to discuss the price with you. If you're at all interested, please send me an email. Because we're a global company and this webcast is being broadcast to everyone in the world right now, as well as people all over the globe are going to be watching the recording later, our prices vary according to what country you're in, what currency, and so on. So I'm not going to discuss currency and pricing now, but I'm happy to discuss the cost depending upon where you are in the world. To give you a little bit of a better idea, we have packages that include one. So if you're a teacher and just want one login for yourself, we can do that as an annual subscription. We also have packs of 50 logins and 500 logins. So depending upon if you want it for single use for you and the class, or have your classroom use it with a 50 seat, or if you want your entire school full, the 500, or your district, then you can use that as well. So that's the lowdown. You have it for free if you join this contest for the next month and a half. You can learn more on our community, join the community, and the blogs that we put out to sign up. It's quick, it's easy, and then you can use the tutorials. So great question. Thanks, Rosalie.
Great, thanks. Okay, how can I find out more information?
Yes, more information, sure. The Hexagon Geospatial website. So I'm going to pop open here one of our web browsers, and I'm going to go to the Hexagon Geospatial website. And here is the main page. And you've got all kinds of different categories at the top here. You've got a map exchange, which is the store. You have as well, if you want to find information on the community, you can look at resources, resource library, and community. And if you can't remember all of that, go to the little search here and type in community. Quick and easy to find where it is. So do a search on the community. You're going to see here, how can we help? Select that option. And then you'll see links here to the support portal, and here is the geospatial community. You can click on it, and it's going to bring you to the community where you can find out answers, you can become a part of discussion boards, share ideas, share even some of the materials that you've put together with your fellow teachers. So a great place to connect. If you're interested in looking at even more areas of our education and what we offer for education packages, a great option is to look under resources and then education programs. Okay. We've got several different programs underneath here, grants, partnerships, all really, really interesting stuff for you to explore. So thanks for that question as well, Rosalie.
Thanks, Mike. How do I sign up for the user community?
Yeah, so that would be going to the community where we just were, but I'll go ahead and map me here to the community. You need to register. If you haven't registered on our community yet, you simply need to click register, and then you're going to be taken to this page. So you type in your first name, last name, email, etc., and you're going to register for the page. So that is the community itself. Once you log into the community then and are a member of the regular Hexagon geospatial community, then you can become a member of Hexagon Geospatial U. This is the closed academic community. So once you're a member of the regular community and logged in, you can come to the geospatial community to learn more, and you'll need to apply here. You'll fill out one more short form, and that form we will verify that you are from either a university or a school, and then we'll send you an email when we give you permissions, and then you're able to go into the community and you're able to learn a lot more about the different tutorials and so on. So I'll just bring up that one more time. And you can look at the Smart Maps curriculum. The Smart Maps curriculum looks like this. So once you're a member of the community and you have permissions to Hexagon Geospatial U, then you can see this page. And this page gives you getting started with Smart Maps, so how to set up the administration. Really quick and easy. I've got on this page movies, so a demonstration video, a PowerPoint, as well as a step-by-step tutorial. So any of those three options to get you up and running. Then we've got some additional examples. I showed you 4 today. There are different ones here as well that you can explore. If you want to download the actual tutorial, you can use this one right here, the 2018 Analyzer Smart Map Training Step-by-Step Tutorial. This gives you the example data and it gives you the PDF. So once you've signed up then for the contest, then you're able to use the tutorials on that page to download a PDF and the example data and walk you through the exact steps on how to use it. And then there's even example data on that page that you can download as well. Okay? So
Perfect.
Thanks for that.
Yeah, thanks. Okay, last one. I am definitely interested. How can I contact you once more?
Yes. So please, if you're at all interested in learning more about this, contact me at mike.lane@hexagon.com. We can set up a meeting, WebEx, where I can go over more specifics. We can bounce ideas off one another. I can give you additional demonstrations on more specific things that you're interested in. We can talk about packages. We can talk about pricing, how many, what to do. I'm happy to set up those meetings with you privately so that you can really learn more and understand how you can optimize this platform in your curriculum and in your classes in school.
All right, wonderful. Thank you, Mike. We are out of time, so for any other questions that we didn't get to, we will get to those offline. So thank you, everybody, for attending. And we will also be sending out the recording. Thanks.
Yes, the recording will come after, so please watch. Thank you.